Hello, everyone. Welcome back to learning more about chemistry with me. Today, we are going to be doing our last lesson on organic chemistry. It only has been a couple lessons, I know, but because of this environment, I can't just teach everything that we normally would teach. But if you're interested in learning more about organic chem, I think it's a super interesting topic to learn. um, welcome to use the Hampton textbook and pick up any topics that I did not cover with you. And there are only a few, honestly. If you look through it, I did, I do manage to cover most of the topics that I think that are very important with you, and they're very fundamental to learning more about organic chem in the future. So today is our last lesson, and yeah, I hope you guys are enjoying it. So before we move on to today's topic, which is in front of you, hope you have the notes ready from the printout. I just want to I just want to go over one question I actually did wrong with you. Thank you to a very smart student who picked this up, and it was from last day. If you have your last day's notes with you, um, it's on the topic of alkyl halides. Okay, so right part B right here, example 6. Okay, so a very smart student picked this up, and thank you, Jeff. And I actually did number 6 wrong. Okay, so instead of, if you take a look at how I highlighted the parent chain, I highlighted 5 carbons in a straight chain as pentane here. But in fact, you can actually highlight an even longer parent chain. Okay, so for to deal with these giant molecules, sometimes you have to really look carefully to pick up, what is considered as the longest carbon chain. So I'm gonna erase, everything I can here. So instead of highlighting, going straight, we could actually go from here, 1, 2, 3, and then turn down, 4, 5, 6. Okay, so this is actually our longest parent chain. Okay, and with that, then the side chain would become right here, this ethyl group. Okay, so 1, 2, 3, and then 4, 5, 6, like so. Okay, and I encourage you guys to pause here and to name this molecule again. Okay, so erase last day's name. The name that I have down below here is incorrect, so this is wrong, and fix it. Okay, so C is before E, so still coral goes first. So we still have, oopsie, we still have 2,2-di coral, and then now we have an ethyl group instead. So it's 3-ethyl, and the longest parent chain is hexane. Okay, oopsie, spelled it wrong. Hexane. Make sure you guys know all the spelling for the 10 alkanes. Okay, so this is hexane, 6 carbons. Okay, so that's from last day. So please make sure you fix it. And now we are moving on to the last topic of today. And so you guys we've been dealing with alkanes. Alkanes means these guys, right? The 10 alkanes ends in ane. That means they are single bonded um, chains, and they are called saturated. Okay, saturated means every single carbon is saturated with hydrogen. Okay, so like ethane here, every single carbon is saturated with hydrogen. So maximum is 3 here on each carbon. So these are called saturated chains. Now today we're going to learn 2 new groups called alkenes, ends in ene, alkenes, and ends in Y-N-E, called alkynes. So again, we're definitely learning a new language here. So alkenes, that means having some double bonds. And if whenever they have double bonds, it's called unsaturated. Okay, so meaning that they have double bonds, or if it's alkyne, Y-N-E, is having um, triple bonds. Okay, so I'm just going to write lines here. Triple bonds for alkynes, alkenes having double bonds like this. Okay, and they are both unsaturated. That means they are having, either double bond or triple bonds. So, everything, the name structure is the same, but we just changed the ending to either ene if there's double bonds, or yne if there are triple bonds. And a lot of the names, when we name alkenes and alkynes, they are quite similar. Okay, so I'm just gonna go through it here. You might feel like, oh, very overwhelmed, but when we do examples, it will make more sense. Okay, so I'm just gonna quickly go through the rules with you here, and you are going to use a number to indicate the lowest number of carbon involved in the bond. So you want to name where is the double bond or where is the triple bond. Okay, so we'll go over that. But the exception is there's an exception. You do not need to locate the double bond if it starts on the first carbon. Okay, unless there's a substitution. That means there's a side chain. Again, we'll go over that in a set. And you're going to name the parent carbon chain just like before. So if it's 2 carbons, it's F. If 3 carbon is prop, and so on. And so now if there's an alkyl group attached to the parent chain, and there's also double bond or triple bonds involved, you want to give the carbon, the double bond or the triple bond, the lowest number, and also give the alkyl group the lowest possible number. Okay, so we always try to give them the lowest number possible. Okay, and again, the priority is you're going to give the lowest number to the double bond and triple bond. Okay, and the last two rule is quite simple. Whenever there's a double bond, you're going to change the ending to ene. When there's a triple bond, you're going to change it to yne. Okay. All right. So let's take a look at here. Um, for teaching things like this, I wish I'm in front of you to actually show you the actual molecular model, and I can build a model and have it rotate and demonstrate it in front of you. But for now, you have to I'm just going to use the MoView program again, but you just have to kind of use a little bit of your imagination as well. So, um, so let's take a look at ethane. So you guys know ethane, right? 2 carbons, and it's all saturated with 6 hydrogens attached. And you have to think about the nature of this bond. Between carbon and carbon is a single bond. So you can imagine these 2 carbons can rotate, right? And can rotate in 360 degrees, and they can rotate. Okay. Now, when ethane become ethene, okay, ene, and that means there's a double bond in between right here. Now these 2 double bond will lock the 2 carbons completely. Okay, and so that means the bond in between, the double bond in between, it cannot rotate anymore. Okay, so now I'm going to quickly show you the MoView, this program here, and hopefully you can understand it a little bit better. So here, this model here, right here, this is ethene, right? The 2 big balls here, it's the 2 carbons, and you can imagine, because there's just a single bond in the middle, imagine you can rotate it, and all the hydrogen can basically go around and spinning around carbon. Okay, so the bond here can be rotate and it's very flexible. Now I'm going to change that to a double bond. So here, oopsie, I'm just going to erase this one. So double bond here. So now this become an ethene. Okay, so here I'm going to show you the 3D model. So ethene, as you can take a look at here, there's a double bond in between, right? And it basically, it's hard to really show you, but you just have to imagine. You can see when there's a double bond, it basically locked the two carbon atoms in the middle. Okay, and as you can see, the model become like a plane. Okay, so it's no longer like um, it's quite rigid. It's called a plane. Okay, it's one single plane here, as you can see from this view. Okay, and that everything is logged and it's all in one plane like this. Okay, and you can also see that if I show you the ethine. So when it's a triple bond, it's called so ethene, and ethyne, YNE. So with a triple bond. So now, oopsie, I'm just gonna erase this one. If you take a look at the ethyne, a triple bond, again, it's just like a straight line here. Everything is locked, very rigid because the three bonds in the middle completely lock the two carbon atoms in the middle. And it's just one straight line. It's a plane, it's a straight line, it's very rigid. Okay, so I hope you guys can understand that. Hopefully, if you guys, we're going to see each other in June, I can show you the model in real person. So the ethene and also the ethyne, they cannot rotate. Okay, the bonds between carbons can rotate, and this is quite important for later on when we talk about how to name different structures of double bonds. So let's move on. Um, Here, one of the rule is if the double bond starts on the first carbon, you do not need to name it. So for example, this example 2 here, I have 5 carbons, right? So we have carbon 1, 2, 3, 4, 5 carbons. So this is a pentene because there's a double bond, and the double bond begins on the first carbon. So we always try to give the double bond here, it's between 1 and 2, right? So we want to always give it the lowest number. So this is actually 1 pentene. And because the rule is, if it starts on the first carbon, you actually don't need to say it's 1 pentene. You just call it pentene like this, okay? Now versus, let's take a look at 2 pentene. Oh, this picture is a little bit blurry. I will zoom it out. Okay, so versus 2 pentene, just going to add in the lines here. So now we still have 5 carbons, so you want to give the double bond the lowest number of carbon. So now you have two choices, just like everything before. You always want to see if you want to name it this way, 1, 2, 3, 4, 5, or you want to do the opposite way, 1, 2, 3, 4, 5. Okay, so you want to go left to right or right to left. So again, the rule is you always want to give the carbon where the double bond begins the lowest number. So in this case, if you go with the bottom one here, the double bond begins between the number 3 and 4. Okay, so this one, if you do it this way on the bottom, you're going to call this 3 pentene. But in fact, you should have go with the top way because you want to give this carbon right here, it's the second carbon, the lowest number. So this is called 2-pentene because the double bond, 2-pentene, because the double bond is between the carbon 2 and 3. Okay, so this is 2-pentene. And for pentenes, there's actually no 3-pentenes because if you draw the double bond right here, it also become 2-pentenes. Okay, so that's where how you name double bonds. We call this guy 2-pentenes. So here the notes here on the bottom basically says I want to give the double bonds the lowest possible number. Okay, so now let's move on. And so what if the alkenes has substitutions? So substitutions means like side groups, side chains, okay? And we are going, the rule is numbering starts nearest to the double bond. So we always want to give the priority to the double bonds. We want to give the double bond the lowest numbers. Okay, so take a look at this molecule down on the bottom. Okay, so just ignore the name for now. Just so we are going to try to name it. So again, the double bond is on the right hand side. So obviously, you're going to start naming this way: 1, 2, 3, 4, 5. Okay, so again, this is a pentene because um, there are 5 carbons. Okay, so pentane, you just change it to pentenes because there's a double bond. Okay, and so the priority again, you want to give the carbons um, the lowest number of the lowest number, okay, to indicate its double bonds. And then the side chain, this is the substitution, that's the methyl group. Okay, so therefore the name for this molecule is right here. So it's the methyl group happens on the fourth carbon right here. So we call it fourth methyl, right? And then the double bonds begins on the first carbon. So it's 1 pentene. Okay. So notice before when if it's just pentene like this, we don't call this 1 pentene. All right, because just if you just say it's pentene, that means it's 1 pentene. Okay. But when there is substitution, like a side chain here with a methyl group, you are going to call you have to add in the one, okay, and then put the branch at the front, okay. I hope it makes sense. So again, if don't know how to name these guys, go back to this sheet that at the very beginning of the organic chem. So we basically have, well, we don't really have methane because there's only one carbon here, but all the rest you just change the name to ending. Okay, ethene, propene, butene, pentene, hexene, right? Heptene, and so on. Change the ending to ene. And for the triple bonds, same thing. You're gonna call this ethine, propyne, butine, pentyne, um, hexine, heptine, octine, right? And no nine, I guess, and decine. Okay, and try to say this to your parent. Your parent will be like, "What? Are you from a alien world or something? Talking about nonsense." So yeah, so this is the new language that we are using. Okay, so moving on to um, alkynes. Okay, so alkynes ends in YNE. So I just review how to kind of pronounce those names with you. So it contains carbon-carbon triple bonds. Okay, so I already show you how it looks like. It looks like a straight line when there's a triple bond, and it's unsaturated because it's not completely filled with hydrogen. Okay, and let's go for some examples. So the ending ane, change it to yne. So ethane, 2 carbon becomes ethine. Okay, and I already show you the structure here. Carbon-carbon with triple bonds and hydrogen. Okay, so it looks like a completely straight line. Okay, so that it's basically 180 degrees to each other, to and very, very rigid, and you cannot rotate it. Okay, so that's triple bonds, and now let's do some practices with both alkenes and alkynes. Okay, so it's all mixed here. So the first one here is, these two are the same. Okay, so the first one on the left hand side here, it has a little bit of the skeletal structure, but it's actually the same thing if you look closely. And this one is the condensed structure. So when I expect you to draw, I do expect you to draw the condensed way and also the full structure. Some people find the skeletal way as a little bit strange. So for the skeletal, for now, you just I do expect you guys to be able to read it and decode it and be able to name it. Okay, so let's take a look at the structure on the left hand side here and see how are they the same. So let's count carbons. 1, 2, 3, 4, 5, and 6. 6 carbon straight chain. Okay, so you can this way I go from left to right. Now you have a choice to go from right to left. Let's check that out. 1, 2, 3, 4, 5, and 6. Okay, and now if doesn't for this one doesn't matter if I go left to right or right to left, the double bond here is actually between carbon 3 and 4. Okay, so you are going to give this one the lowest number, which is carbon 3. So therefore this is 3 hex, right? So 6 carbon hexene because it has a double bond. So it's not hexane anymore, hexene, 3 hexene. And the structure on the right hand side here is also the same. For now, there's actually a little bit, in terms of orientation, is a little bit different. But anyways, for now, just double check. 1, 2, 3, 4, 5, 6. So this is actually also hexene, okay, with the triple bond, I mean the double bond in between the carbon 3 and 4. All right, so that's how you would name this one. And again, take a look at this one here below. These two left and right, they're the same structure, but we can also double check. So 1, 2, 3, 4, 5, 6. Okay. Um, yeah, these two structures is basically yeah, this is more condensed. The one on the right hand side is more condensed, but the one here on the left hand side is not as condensed, but it's not as full. If you write the full structure, you would have put all the hydrogen like individually sticking out like this, right? So that would how I would consider as a full structure, but this is just more condensed, but with the stick in between. So this one, if you go from right to left, 3, 4. So it's the same thing for this one. The triple bond is between carbon 3 and 4. Doesn't matter if you go left to right or right to left. And this one is the same here on the right hand side. 1, 2, 3, 4, 5, 6. Okay, 6 carbon. So we're going to call this guy 3 hex, YNE, hexine. Okay, hexine meaning a triple bond. Okay, so let's do something a little bit harder. We have these two different structures on the bottom, skeletal structure. If you guys want, pause here and um, try it yourself first. Okay, try to name both of these guys. Otherwise, do it with me. I do want to practice with you for this. So here we have the triple bond. So as you can see, the triple bond is more close to the left-hand side. So for this reason, I'm going to start naming the carbon from left to right, okay? Because I do want to give the lowest number to the triple bond. So as you can see, the triple bond begins on the second carbon here, between second and third, okay? So this is going to be 2. Oopsie. And then that's 3 and 4, 5, 6, 7. Okay, so this is my longest parent chain, and my side chain here, you should be able to tell what is this. Okay, so this is an ethyl. Okay, because there are 2 carbons here, so this is an ethyl group. So we are going to name the side chain, the substitution first, the ethyl group, which is on the 4th carbon. So this is 4 dash ethyl. Make sure you guys use dash, okay? Connect number and words with a dash. So 4 dash ethyl, and then I'm going to locate the location of the triple bond. So this is 2 dash, and the parent chain is hepta, because there are 7 carbons. Okay, so heptine. Okay, so that's how you would do a chain with a triple bond. Moving forward, let's take a look at this one. Um, so for this one, the double bond is kind of in the middle, but we have this side chain on the left hand side. But we should double check. We always want to give the double bond a lowest number. So we can try go from left to right. 1, 2, 3, 4, 5, 6, like this. Or we could, I'm going to use a different color. 1, 2, 3, 4, 5, and 6. Okay, so which one are we going to pick? Are we going to pick the red color one or the green one? And I'm sure you guys got it right. We're going to pick the red one because we know the green and red, both of them is 3. The double bond begins on the third carbon, right? But we also want to give the side chain here the lowest number, okay? So we're going to keep the red one, okay? So that way the double bond is the smallest number and also the side group. So the side group here, we have a methyl group because it's just one carbon here. So it's 2 dash methyl and dash, and the double bond begins on the third carbon, hexa. And with the double bond is hexene, like this. Okay, there you go. All right, moving on, next page. Um, gonna have you guys do the opposite. We did all the namings. Now let's do the drawings. So pause for a second and try to draw these yourself. Um, and give it a try. I'm sure you guys can do it. Okay, so I'm gonna show you the first one together. So this one is cyclopentene. Okay, so that means a 5-carbon ring. And when you draw a 5-carbon ring, so basically it's always considered as a 1-pentene. Okay, like this. So you can draw the double bond anywhere you like. It could doesn't have to be at this location. You could draw it like here on the bottom. Okay, so it doesn't matter. Okay, so that means the one pentene cyclopentene starts right here. 1, 2, 3, 4, and 5. Okay, and then now you're going to add in the methyl group. So 3,3-dimethyl. That means it's on the third carbon on the ring. So I'm going to erase this 3 here and then just add in the 2-methyl group like this. Okay, so I'm just going to draw skeletal like so, and it's just quicker. Okay, but if you want, you can just add in the CH3, CH3. Okay, so I'm going to pause it here and then do all 3 at the same time and then show you guys the final structure. Okay, so that's how the next two looks like. I always like to do it from left to right, so my double bond is on the left-hand side. But if you wish, you can always start from right to left as well, and your chain will be going from left to right, 1 to 5. Yeah, so it's your own preference. Okay, and I will draw the last one with you just in case some people didn't get it. So pen penta 5-carbon. So I know my triple bond begins on the first carbon, so it says 1 peptide. So I'm going to draw a 5-carbon chain like this. Okay, and then I'm going to add in the 4-methyl. So this is my first carbon, so this has to be my 4th carbon. So CH3 on the 4th carbon, and that's it. That's almost done. And now you just need to add in the hydrogen, right? So remember carbon, they always bond to 4 things. So the first carbon here is already bond to 3 hydrogen, so you need one more. So you can draw the hydrogen on the outside or inside, it doesn't really matter. Second carbon here is already have 4 bonds, so it's all set like, completely bonded. And the one in this one here, the third one, you need 2 hydrogen. The fourth one, you need one more, right? And the last one, you need to have 3. Okay, so each carbon has 4 bonds. Do the homework later. I will summarize the homework on the OneNote as well. So let's do that later. So another next moving on to the little bit to do with the geometry of alkene and alkyne. The nature of these two types of structures, they are very rigid. They cannot be rotated, right? So as a result, this rigid structure has the consequences of cis and trans isomerism. Okay, so this is something that we're going to be talking about. It gets a little bit more complicated, but it's okay. I'm sure you guys can manage it. So there's because of this rigid structure, because of the double bond, triple bond, there's a cis and trans isomers. uh, for the same name of the molecule. Okay, so to find um, to determine when a cis and trans isomerism is happening, you have to it has to have a double bond that's present. Okay, so the molecule has to have a double bond, and then the so here the other point here is the groups other than a hydrogen atom attached to each of the carbon on both sides of a double bond. So between the two carbons where the double bond happens, um, there will be other groups attached to either side. Okay, and the groups, the third point here is the attached group. They do not have to be identical, but they are not hydrogen atoms. Okay, so I'll show you what I mean by this by showing you examples here down below. Okay, so here we're going to start with talking about cis and trans. Cis is when um, the two groups um, are on the same side of the double bond. Okay, and trans is short term for transverse, that means opposite. The two groups are on the opposite end to each side. So here we have the example of 2-butene. Okay, so I'm going to draw you the condensed form of 2-butene. So it's CH3, CH, CH, and CH3. So this is 2-butene because the, the double bond begins on the second carbon here. Okay, so 2-butene. And as you can see, um, for this structure, there each the where the double bond is, this is the double bond, and each one of them they have one hydrogen, okay, and then they also have CH3 at the end. Okay, so they are quite symmetrical for this structure. Now, for this structure, there are two different ways because of the result of the double bond. So you can either draw it like this when the CH3 and the CH3 they are on the opposite end of each other. So this is called a trans 2-butene. Okay, trans means they are opposite. So these two groups they are not hydrogen and they don't have to be identical, but in this case they are identical. Okay, and they are on the opposite end. Okay, so this is trans 2-butene, whereas cis, meaning cis is the same side. So in this case, you can draw at the CH3, CH3 on the same side. So notice that these two structures, they're called isomers. They are completely different. You cannot just like rotate this bond and change one to the other because the double bond is completely locked. Okay, so that meaning you cannot change from a cis structure to a trans structure without breaking the bonds. Okay, so therefore these two are completely different structures. Okay, so these are called cis and trans isomers, and this only happens when there's a double bond. Okay, and there's usually a hydrogen, um, just one hydrogen each on the double bond, and the ends they are different groups. Could be the same kind or could be different. Okay, and again, I'm just going to quickly show you with this um, illustration here, and hopefully that will make it easier for you guys to see it. So I have double bond here. I'm going to add in the single, oopsie, I'm going to add in the single bond at the end. Now, oh, this is hard. Let's try to draw in. Let's see what it would give me if it's just like this. Let me just have all these extra stuff. Okay, so if you take a look at this, I'm going to change this to a 3D diagram. Okay, so take a look at this molecule here. Is this a cis or trans? isomer for 2-butene. So without me indicating it, the model automatically gave me a trans 2-butene because you can see this CH3 and CH3, they are on the opposite end. Okay, so this is a trans 2-butene. I wonder if it could give me a cis. So just think about it with the double bond here in the middle. You cannot just rotate a carbon and change it to a cis one. Okay. Um, no, actually, you know what? Not gonna waste time here. But this is the model automatically here gave me a trans 2-butene. Okay. Now let's move on. I'm going to show you how to draw them. Okay, so drawing them is actually quite easy, but you just have to be able to recognize that, whenever there's a double bond, it could it could happen that there is cis and trans isomers. Now let me show you one that it's not possible. So instead of this is 2-butene, right? Let me draw just butene. So butene means 1-butene. Okay, so I'm going to draw 1-butene. Okay, here we go. So this is 1-butene. So if you take a look at 1-butene, the double bond is happening on the first and second carbon, right? So this is, um, yeah, so this is 1-butene. Now, this one it does not have any isomers. It only has one structures. And the reason to do with that is it's easier to if you draw the full structure. So for the carbon here, there are 2 carbon. I mean, there are 2 hydrogen. Okay, and then for the second carbon, there's only 1 hydrogen. Okay, and then what is bonded to is, oh, this should be CH2, CH2, and CH3. So as you can see, for this is 1-butene, 1, 2, 3, 4. So as you can see, what is next to the carbon bond, the carbon-carbon double bond here, there are actually 3 hydrogens, right? So there is, in fact, it doesn't have isomers because it doesn't matter how you rotate it, there won't be any cis and trans molecule because like this group, there's nothing that's opposite to it because there are all 3 hydrogens next to the carbon-carbon double bond. Okay, let me give you guys more structures so it will make more sense. Okay, so how to draw a cis and trans model here is, let's start with double bond. Okay, so double bond um, right here. So it says it's 2 pentene, right? So I'm just going to use this has to be carbon 2 here. Okay, and it's trans. That means I'm going to draw the hydrogen and hydrogen in opposite end. Okay, CH, they're on opposite end like this. Okay, and then so I need a carbon 1, right? So carbon 1 would be CH3, and that's carbon 2, 3, and carbon 4 on the opposite end, CH2, and then carbon 5, CH3. Okay, does it make sense, guys? So here we have carbon, um, we have these 2 groups, CH3 on the opposite and these group on the opposite end. So that's why they are called trans. Okay, they're on the opposite end. Or you can just think of also the hydrogens are on the opposite end. Okay, and this is a 2-pentene because there are 5 carbons straight. Okay, so imagine if the question did not indicate whether it's cis or trans, it just said, oh, 2-pentene. So how would you do 2-pentene? You would just do a normal one, right? Like, oh, see, you would just do like, let's do the straight chain carbon first. So 1 double bond here, second carbon, 3 and 4 and 5, like this, right? And then now you would add in the hydrogens, CH3, CH, CH. Oopsie, getting messy here. I'm just going to erase this part. Um, CH2, and CH3. Okay, so this is 2-pentene. This is how you would normally do 2-pentene. Now the complication adds in here is now you have to deal with the cis and trans isomers. So basically how I did this one is I turned this one into this red structure here. Okay, and I'm going to do the cis to show you how to do that as well. So basically I take these two hydrogens right here, the highlighted one, and then turn it into the opposite end like this. Okay, so I'm drawing like almost like a faux structure sticking out the hydrogens. Okay, so that they are on the opposite end. And then this group here goes right here, and then this group here goes right here. Okay, I use different color. This one goes here. Okay, does that make sense? So now I'm going to do the same thing with the cis. So cis, I'm going to do the double bond in the middle, and I'm going to do the hydrogens on the same side. So the highlighted yellow hydrogen on the same side, so they are cis. And then the other two groups, the CH3 on the opposite end, I mean on the same end with CH2, CH3. Okay, so this is the cis isomers of 2-pentene. Okay. If you didn't get it, try rewinding the video and listen to what I just said again. Okay, so cis is on the same side, trans is on the opposite side. Okay, so give it a try. I will try this number 3 with you as well. Trans 3 hexene, 6 carbons. Okay, so how I would do this one is I'm going to do just a double bond like this in the middle. So that would be my 3rd carbon and the 4th carbon here. And since it's trans, so I know it's my hydrogens would be on the opposite end like this. Okay, and then all I need to do is add in the rest of the carbons on the opposite end. Okay, so I have my carbon 2, CH2, and then my carbon 3, CH3. Okay, on one end. So that's 1, 2, 3, 4, 5, and 6. Okay, so that's trans 3 hexene. Okay, now example 4, almost the end, guys. Hang in there. Example 4 is just indicated as 3 heptene. Okay, so it doesn't really indicate the cis or trans isomer. So for this, you don't need to worry about it. But in fact, for this one, it does have 2 different isomers as well. Okay, so for this, you just go, you can do 7 carbons straight, 5, 6, and 7. And then the double bond begins on the 3rd carbon. So I'm going to add in my double bond here between carbon 3 and carbon 4. And then I'm just going to add in the rest of the hydrogen. Okay, so the hydrogen you can do it like on the left or on the right. Okay, so it doesn't matter. CH3 at the end, CH2, CH, CH, CH2, CH2, and CH3. Sorry, it's a little bit messy. Okay, so as you can see for this one, it does have an isomer because these 2 hydrogen can go either way, can go opposite end or it could go on the same end. Okay, so it does have 2 different isomers. Okay, this is going to the end, almost the end of all the naming structures. Obviously, things could get more complicated. There could be like 2 double bonds or 2 triple bonds, and the name does get a little bit more complicated, but we are not going to get into those anymore. If you guys are interested in more chemistry, I'm sure you will encounter them later in your future. Let's wrap it up with these 2 molecules, and then I'm just going to talk about one more things, and that will be it for today's class. So now here, for this one, if you take a look at, oh, this is missing. For example 5, there are actually 2 different models here. Okay, so I'm just going to separate it into left and right. You can see they look almost the same, except that the chlorine groups, these two are on the same side, and these two are on the opposite side. Okay, so as you can see, this is almost like the hydrogens. The hydrogens are on the opposite end, but this one, the chlorines are on the opposite end. Okay, so this is a alkyl halide because there are halogen groups attached to it. So you might have guessed this is also the cis and trans isomer for this molecule. So let's try to name it just the normal way. We're gonna give it the names of the carbon: 1, 2, 3, 4, 5, and 6. 6 carbons straight, and the double bonds happens on the second carbon, right? So this is a 2 hexene. Okay. Now the coral groups here happens on 2 and 3 carbons. So 2, 3 dicoral, okay, and dash. This is a 2 hexene, 6 carbons. Okay, so basically these two structures you can call it almost the same name, but um, now with the two chlorines on the same side, for the left-hand side one, we're going to call this one cis. Cis dash 2, 3 dichoral dash 2 hexene. Okay, make sure you have all the dash. Everything is connected in one straight line. And as you may guess, the second one on the right, you just need to change the word trans, and everything is the same as the left-hand side. Okay, so I'm not going to copy it. You can copy it down, and homework is on everything I summarize at the end of the class notebook. And actually one more topic, there's actually one tab that's called functional group on your page, on your class notebook, and it looks like this. Okay, so everything we learned so far in organic chem, those are the the basic organic molecules like alkane, alkynes, alkenes, but it gets more complicated. There are other groups that could attach to those chains. Okay, and one of them you may know is alcohol. Um, so for these functional groups, I do expect you guys to know them, to kind of recognize them, but you don't really need to learn how to name them. Okay, but if you're going to pursue further on, you definitely is going to learn them. And also Hapton has some example of how to name them as well. If you guys are interested, um, check out Hapton at the end of the unit. And again, I just want you guys to kind of get familiarized with this page called functional groups. I'll take a look at the go over the first one with you because I know alcohol is something that you guys are familiar with. So the R group here is on the left hand side is the generic group. It's basically, and it could be could be like ethane, right? So like 2 carbons, or could be propane, like 3 carbons, and so on. And the alcohol is adding this functional group called OH at the end. So all alcohols, all the alcohols that you use, like all the wipes that you guys all the wipes from Lysol, everyone's like hogging all those wipes, all the hydrogen peroxide. Actually, that's not alcohol. Anyways, but just got distracted with all the sanitizer. So alcohols is any of the all these alkane groups and attached to OH group at the end. Okay, so for example, ethanol is one of the alcohols that you may know. The way they name ethanol is just ethane, right? And they add the ending ol because alcohol ends in ol, right? So anything you see ol at the end, you know it's an alcohol. Propanol, propane, right? So 3 carbons propane, and you just by adding an ol at the end, it changed to a name of the alcohol. Okay, so that's one group that you should be quite familiarized. There are some acid groups, ether, ketones. These are really common really common organic groups. Okay, so now you know the three groups: alkane, alkynes, and you should kind of get used to these other functional groups as well. Okay, so check it out. And that's all I'm going to be cover with you for organic chem. And next unit, we're going to start on solution. I'll do a couple lessons on solution because that's a very important unit for chemistry 12. Um, yeah, that's all for now. So the class, the lesson is quite long today. I hope you guys learning a lot and keep working hard. I will see some of you in June 1st. If not, we'll keep on doing more online lessons like this. I'm sure this is going to be moving forward. It's going to be a it's the lessons are mostly covered online like this, I'm pretty sure, because I'm sure some of you won't be feeling comfortable going back to school. And yeah, just from the survey I yesterday I saw that a lot of you are most of you are adjusting well to the online environment. It's not the best, it's not for everybody, but I like the fact that you guys are coping, you guys are trying your best. So keep up the good work. And just a couple more weeks of school left, right? So I think it's like 5 more weeks, including this week. um, yeah, so if there are any questions about organic chemistry, just email me or share in the channel, and I'll reply you very soon. Okay, so take care everyone. I'll talk to you soon. Bye.